Hello and welcome back to Precalculus. Our last lesson was using the law of sines to solve oblique triangles. We are now going to be using the law of cosines. It's not quite so simple a formula, but it's nice because there's no ambiguity at all. And we will talk about area of triangles and applications as well. Remember that you are in an oblique triangle, so you cannot use SOHCAHTOA. And also remember that the labeling of the triangle has uppercase for the angles, and then the same letter is the side opposite the angle. The law of cosines requires having an included angle, which means that you have, if you look at this formula, you would be finding side A, and on the other side of the formula you have the angle and then the two sides that form the angle. If you look at the diagram, you have the angle A here, and then B and C form the angle. So you have all three letters represented. That's a clue, and we'll talk about that again. Now, if you had a different angle, say that you had angle C, for example, and it would have A and B around it, then you would rewrite the formula. Start with the included angle, cosine of C, and the side opposite will be notice there's an A here and there's an A here, so substitute those first, and then everything else, just make the formula the other two letters. So it'll be A squared plus B squared minus 2AB cosine of C. So that's how you adjust for the formulas. Or if you were looking for an included angle B, then you would have a B squared here. The other two letters would be A squared plus C squared minus 2AC cosine of B. So observe the pattern so that you can rewrite the formulas. Now our first problem, we're going to be finding an angle. If you're finding an angle, that's when you're going to use this form of the formula. You could prove to yourself or look in the book and show yourself that they are the same formula. But in this one, we're solving for the cosine of the angle. Notice that in order to find the angle, we need to know all three sides, and we'll talk on the next slide about adjusting the formula. Our first example is an SSS triangle. In other words, we are given three sides, A, B, and C, and our first job is to find an angle. Now the instructions that are written here to find the largest angle opposite the largest side first, that is based on if you are going to use the law of sines. If you find the obtuse angle first, then you don't have to worry about two answers for the law of sines when you use it. However, as I show here, if you use only cosine, law of cosines, then you don't have to worry about these instructions about which angle you find first. Because what happens with the law of cosines is, remember, your positive cosines are in first quadrant, those would be acute angles. Your negative cosines are in second quadrant, those are obtuse angles. So you don't have to have any worries about what the angle is, and you just go ahead and use the cosine for the whole problem. So if you decided, in this case, C was the highest, the longest side, so I'm showing here finding C first. Then you have to adjust the formula. So because there was an A as the included angle before, now we have the C as the included angle. So notice that the minus A squared on the top becomes a minus C squared, and then you fill in A's and B's for the rest of the formula. That's adjusting the formula. The other thing you might do wrong, and you should make sure you're getting these exact same answers on your calculator, you might forget to put parentheses in the top and the bottom. Notice this one turns out to be a negative cosine, so when you do the inverse cosine, which if you have done this fraction, you could just do the cosine -1 of A and S, key on your calculator, which is the answer, which is what is on your screen, and you'll get 93 degrees, which you notice is an obtuse angle. Then if you go ahead and use the cosine for the law of cosines for angle B as well, once again you adjust the formula. Instead of the A, you have the B. Instead of the minus a squared, you have the minus b squared on the top, and the other two letters fill in the rest of the formula. Once again, need parentheses around your fraction top numerator and denominator, and then you get your angle B, which is 49 degrees. Once you have two angles, then you subtract to get the third angle. Now, what if you had gotten one of the acute angles first? Suppose you just decided, well, the formula is an A, so I'm going to find A first. And A turned out to be 38 degrees. Then, if you were going to use law of sines, and you were finding angle C, you would end up with, when you do your inverse sine for the angle, you would end up with an acute angle, not the 93 degrees. So that gets very confusing if you're going to use law of sines. So if you're going to use the law of sines, make sure you find the largest angle first. That'll be the obtuse angle if there is one, and then you don't have to worry about it. In our next example, we're given side, angle, side. How do you know? You're probably wondering that. Well, if you look at what you're given, you have two sides and an angle, but they're all different letters, and that indicates that A is the included angle and B and C are the sides that make angle A. And notice, if you had tried to use law of sines, it would be impossible because you have a B, a C, and an angle A. You have little parts of all three fractions, but you need to have three parts of just two fractions in order to use law of sines. So that's another clue that it's not going to work. So you look at your formula, and your formula is written as a squared equals b squared plus c squared minus 2bc cosine A. If you want to, you can just find a squared and then take the square root of it, or you could actually put all of this into your calculator at one time. Just be careful. Whatever your calculator requires, you're going to have to make sure you close the parentheses around the square root, or in some cases cursor off of the square root to make sure that you have everything under the square root that you're taking the square root of. So check these answers. If you're getting them right, you're using your calculator, great. The only other thing on this one I wanted to point out, if you're going to have to use a rounded value in your next calculation, I have here used 5 decimal places. That is very sure and right and will give you very good answers without rounding errors. However, usually 4 decimal places is going to be okay also, but make sure you use 4 decimal places. Don't just use tenths. You're going to get huge rounding errors, and you don't have any choice here. You have to use a number that you've calculated in a previous calculation. So if you want accurate answers, you're going to have to carry 4 decimal places at least. And once again, you have a negative number, and it turns out to be an obtuse angle. So, warning again, if you're going to use law of sines, make sure you're aware of obtuse angles, and you can see after you find that first side 9.7, you know C is the longest side, so angle C is the chance of an obtuse angle. So the best way to get around that, just use law of cosines for everything. And then your third angle is 180 minus the sum of the other two angles is 13. Now we have 2 formulas for finding the area of an oblique triangle. It's much easier if you have a right triangle or if you have an altitude of a triangle, but you can find the area of an oblique triangle using this formula. It uses the sine value. So this is the formula, area equals 1/2 AC sine of B, and you can only use it for included angles, which you can tell once again you have an included angle because you have angle A, and then you have the other 2 letters B and C make up angle A. So once again, you have to adjust the formula, make sure that your included angle is in the formula. So your area is going to be 1/2. Now we want angle A, so we're going to put the other 2 letters, B, C, and then sine of A. Make sure you check the formula sheet to remind yourself it's going to be a sine, not a cosine. Then it's simply a matter of filling in the formula and making sure that you use units. If you have feet as length, then your area is going to be feet squared. Now we can also find the area of an oblique triangle if we only know the three sides. One choice you have is to use law of cosines to find an angle, and then you would have an included angle that you could use the other area of the triangle formula. But if you have access to Heron's formula, which is this funny looking expression here, that would actually, you could directly find the area of an SSS triangle. So you're given three sides. S actually means semi-perimeter. You remember that the perimeter of any object is you add all three sides. So for the perimeter, you add the 5 plus 5 plus 4, and then semi means a half, or divide by 2, like a semicircle is half a circle. So you have the perimeter divided by 2. Now this one's really nice. It comes out to whole numbers. They're not all that nice, but it's just a matter of cranking out the formula, then taking the square root of, and then substituting in s, s minus a, s minus b, s minus c. Once again, closing your square root before you take the square root of it. For application problems, you're going to have to decide which formula to use. So I want you to make a decision on that. Remember, law of sines, you do not have an included angle, and law of cosines, you do have an included angle. So pause, make your decision, and then see if we agree. Okay, the answer is law of sines, because we do not have an included angle between two sides. We actually have an included side between two angles, which is ASA, which we use law of sines. Now, one thing, be sure you do not use right triangle trig for problems that are not right angles. Make sure you're secure on that. So for law of sines, each fraction is going to be a side and its opposite angle. So look at what we have here. We have a side, which is our unknown value, and our opposite angle here. And we have another side. We need the opposite angle to that side. So the very first thing we're going to do is find that third angle. Since we know two angles, we can find the third. So we take 180 minus the sum of the 92 and the 26.8, and we get 61.2. Now we're ready to use the law of sines. So we have h over its opposite angle sine equals 89 over its opposite angle sine, and then we do the math and we end up with 45.8 meters. Don't forget to use units for these. Here's another word problem. See if you can hit pause and make a decision whether it's law of sines or law of cosines. Hopefully you read the problem and labeled what you do know, the 425 from A to B, and then 300 meters from B to C. Now it looks like it should be an included angle, but it's not quite. We have two sides though, and we have an angle in there somewhere. So you just have to use a little bit of your basic geometry and remember that two angles that make up a straight line are supplementary. So angle B will be 180 minus 65, which turns out to be 115 degrees. And now we have our included angle, which means that we are going to use law of cosines. So I've written the formula here, and the first thing we're going to do, because we want to find AC, now AC is opposite angle B, so that's side B. So we need to adjust the formula, put our b squared first, then the other two letters, still stick with the other two letters, and then cosine of b. And then fill in the formula. You'll notice I have labeled here what is A and what is C, but when you're doing cosine problems, it really doesn't matter which side of the included angle you're on. It wouldn't change the problem if you mixed up the order of those too, as long as you have the B in the right place. So watch your rounding instructions. You can put this all in your calculator at once. Your calculator knows the order of operations, and remember units in your answer. Okay, there we have it. Have fun with these problems.